evaluate the function for a specific value of x. What do? Easy. I just plug it in, right? So f of 3 equals what? 2 times 3 to the power of 4 plus 3 to the power of 3 minus 8, 3 to the power of 2 plus 5, 3 minus 7. Long expression. And then I can plug it into the calculator or do it in my head. And the answer is, somebody?
Well, I got you. Okay, so 2 times.
No, that's gone. Can I just write the answer from my...
Sure.
125. Yes. Okay. The thing to remember is if the x is negative, do put it into parentheses when you plug this into calculator, right? Otherwise your answer will be wrong. Put the argument or input into parentheses so that you don't mess.
Put the 3 or the negative 3 in.
Yes, so the value of x, just put it into parentheses every time, right? Before you plug it into the calculator. Questions? Good. So today we are going to learn how to evaluate using the synthetic substitution. So here is how we do it. The first thing to do is to check that your polynomial here, your function, is written in standard form. Meaning that the terms are ordered according to the exponent. You see how I have x to the power of 4 and then x to the power of 3 and then x to the power of 2. Yes, it decreases from left to right, right? So they're ordered. And then I do the following. I copy my coefficients right here. 2, 1, negative 8, 5, and negative 7. So I just copy coefficients, making sure that I don't skip any. What I mean is, if my polynomial has a term for one of the exponents missing, then I need to fill it in with 0. For example, if I have the polynomial f of x equals x to the power of 3 plus 1, you see how I don't have x to the power of 2 and I don't have x? Right? I can rewrite this as x to the power of 3 plus 0x to the power of 2 plus 0 times x plus 1. So the numbers that I copy here would be 1, 0, 0, 1. Okay? Standard one. And we'll practice. Yes.
Where does division come?
Division will be later. Right now it's just substitution. Okay, so I wrote down my coefficients. Now I'm writing here the number that I'm using to evaluate the expression. So 3 goes here. Okay? Now, here is the trick. I go like zigzag. So I copy the first coefficient down, 2. And then I go on diagonal. But before I do that, I need to multiply 2 times 3. So 2 times 3 is 6. I put it right here. Plus 6. Now I have two numbers in the same column. I add them together. So 1 plus 6 is 7. Now again, before I go diagonal, I need to multiply 3 times 7 is 21. Now I add the numbers in the same column. So negative 8 plus 21 gives me 15, right? No, 17. Right? Negative 8 plus 21.
21 minus 8 is 13.
Oh, right, of course. 13. Excuse me. Now 13 times 3 is 39. 5 plus 39 is 44, right? 44 times 3 is 120, 134? Is it 132? 132. And finally, negative 7 plus 132 is 125. This last number is your answer. Notice how we got the same answer as the one above it, right?
But we didn't like do that. We didn't do any exponents.
Yes, we didn't do any exponents. So this was like different method. Right? We didn't have to calculate the exponents. That is correct. But the numbers that you get here at the end will give you the same answer as the answer you would get right here by doing the normal method, the one we just referred. Questions about the method? Okay, let's practice some more. Evaluate using synthetic substitution. So again, the first thing first, I need to check my polynomial. And you see, I have the exponents ordered x to the power of 4, to the power of 2, 1, and 0, which is good, but I have one term missing, right? There is no x to the power of 3. So I will just rewrite it. Minus x to the power of 4 plus 0 times x to the power of 3 plus 4 times x to the power of 2 plus 6 times x minus 3.
What about that zero?
Because I want to make sure that I don't skip that coefficient 0 when I do this, when I do my synthetic substitutions. So now I copy my coefficients. Negative 1, 0, 4, 6, negative 8. I take the number for which I'm evaluating and copy it right here, negative 1. Now I need to do my little zigzag, right? The first thing to do is to copy my negative 1. So the first coefficient is just copied down, negative 1. Now I need to multiply negative 1 by negative 1 is 1. So I put it right there. I go zigzag. Now I have two numbers in the same column. I add them together. 0 plus 1 is 1. I need to go in diagonal, so I need to multiply. Negative 1 times 1 is negative 1. I add the numbers together. 4 plus negative 1 is 3. Negative 1 times 3 is negative 3. Now 6 plus negative 3 is 3. 3 times negative 1 is negative 3. And finally, negative 8 plus negative 3 gives me negative 11. This is my final answer. I just calculated f of negative 1 equals negative 11. Right? So I evaluated my function f for x equals negative 1. The answer is negative 11. Questions? Yes.
So when we're on a quiz or a test or homework, do you have to draw that like weird bar?
Yes. If you ask you to do this, to evaluate by synthetic substitution, then yes, that's exactly what you want to see. Questions? Okay, let's do the next one. So the function fx equals negative 4x to the power of 3 plus 3x minus 5 for f of 2. So x equals 2. So if I write my coefficients right away without rewriting, what is my first coefficient?
Negative 4.
Negative 4. What is the second one?
0.
0. What is the third one?
0.
Ah, 0?
1.
3, right? Because this one is for x to the power of 3, this one is for x to the power of 2, next one will be x to the power of 1, which is just x, right? So it's 3, and then the last one is for the number is negative 5.
So you have to account for all the
You have to,
integration. So
exactly.
that's what I was asking.
Yes, so you have to count for every single exponent starting from the highest one all the way to 0. Yes. Okay, so I wrote down my coefficients in the right order, and now I'm evaluating for 2. Right, so the 2 goes here. The first coefficient is just copied, negative 4. Right? Now I go on diagonal. 2 times negative 4 is negative 8. Now I add the numbers in the column. 0 plus negative 8 is negative 8. 2 times negative 8 is negative 16. Now I'm adding 3 plus negative 16 is
Oh, so
negative.
when you go from top to bottom, you add.
Top to bottom I add. Diagonal I multiply by my x. So now diagonal I multiply 2 times negative 13,
Negative 26.
negative 26. Top to bottom I add negative
Negative
5 plus negative
31.
26, negative 31. That is my final answer. This means that f of 2 equals negative 31. Yes. Mhm.
I don't quite understand the whole, like, 0 times 2 is negative 8.
Not 0. Oh, I'm multiplying this number and this number.
Oh, okay.
These two multiply, give me the one on the diagonal. And I'm adding the numbers in the column, I'm adding. When I go with diagonal, I take this number multiplied by this number. Okay. Yes.
Why isn't that x4?
You mean x to the power of 4? I mean, I can add them as many as I want, but they will be 0, 0, 0, right? So I can start wherever, I will still have the same answer. Because all of these first ones will be 0, 0, they don't really matter. Right, so just start with the highest exponent that you have. Yes.
So that L shape, is that like the easiest method to do? Like, we're gonna do that on even like the more complex problems. This looks kind of weird, so I'm not gonna. Like for the complex, like the more complex problems, we usually making it L nice.
Okay, so after we evaluate the function for a given value of x, if the final value is 0, that value is 0 of the function. Makes sense, right? I use my x, substitute it, get 0, get 0. So if you have a question, determine if the following values are zeros using synthetic substitution. What do we do? We
Wait,
just do this.
hold on.
That-
The value of the synthetic solution is 0, the value is what? That doesn't even
Yes, if the final value of your synthetic substitution right here, right? If this value is 0, the final answer, it means that this value of x is 0 for your function.
Can you go back real quick? I think you need a comma to make it grammatically correct.
Wait,
Where in that?
Shush!
And
Wait, I have a question.
yes,
The second one right there, after the semicolon, is that the x?
x equals.
Okay, I just wanted to make sure.
The 0 that you has a slash on it, doesn't that mean it's not equal to 0? If it isn't 0,
No,
the
this
value-
is just 0 to make it different from all. If it's not equal, it's like that. Not equal.
Okay.
But let me.
Oh, frick.
Okay. So determine if the following values are zeros using synthetic substitution. Right? All I do is do the same. I
One.
evaluate using synthetic substitution. So what I'm evaluating for 1, so 1 goes here. And I write down my coefficients for all the exponents from the largest to the lowest. What is my first coefficient? 1. What is my second coefficient? 0. What is my third coefficient?
0.
0. And the final?
-1.
-1, right? Remember, the largest exponent is 3, so the first coefficient is for x to the power of 3, the second for x to the power of 2, next for x, and the last one is for the number, right?
So the
You
last
make
one is
sure you count for every one of them.
Oh.
Okay, so the 1 goes down, just copy the first coefficient. Now I go by diagonal. The number below the line
Wait.
multiplied by my x. 1 times 1 is 1. I add the numbers top, bottom, and bottom number in the same column. So 0 plus 1 is 1. I go on diagonal, so I multiply 1 times 1 is 1. I add the numbers in the column top to bottom. 0 plus 1 is 1. on diagonal, I multiply 1 times 1 is 1. And then finally, I add together the two numbers. Negative 1 plus 1 gives me 0. So my final answer is 0. That means what?
That is yes.
X equals 1 is 0 of the function f of x. So x equals 1 is 0 for this function, yes.
What do we do for that one since there's no number?
Right. So let's do the next one. And by the way, what does it mean it's 0, right? If I plug this function into my calculator and graph it, what is x equals 1? It will be my x-intercept, right? Right?
Excellent.
Making the connection? Okay.
Yes, yes.
Okay, so let's move on to the next example. I'm evaluating for negative 2, so my negative 2 goes here on the left. I'm writing down all the coefficients, and I ordering them according to the exponents. So for x equals, for x cubed, and then I will take x to the power of 2, and then I need x, and then the number, right? So my first coefficient is what? 1. My second,
Negative 5.
negative 5. Third,
6.
6. And what is my number?
0.
0. Okay, so the first coefficient is just copied down. There's nothing to add. Now I multiply 1 by negative 2, gives me negative 2. I add the numbers in the column together. Minus 5 plus minus 2 is negative 7. I go on diagonal, so I multiply negative 2 into negative 7, 14. I add the numbers in the same column. 6 plus 14 is 20. I multiply the numbers. Negative 2 and 20 is negative 40. And I add the numbers in the last column. Negative 40. My final answer is negative 40. What does it mean? It means that g of negative 2 is negative 40. It means that negative 2 is or is not 0. Is negative 2 is 0? Is not, right? Negative 2 is not is 0 for this function g. Questions?
Give me a second. I need to copy it different.
You have to write out the whole sentence.
Well, as long as you understand it, right? That's how you write. The process. Gives us another chance to process. What is it that we are answering? Ms. Osborne, you want to take over?
Oh, the long division now?
Mm-hmm.
Okay.
I didn't get long division. What are you doing?
So, just before we get into dividing polynomials, okay,
We go back to the basics.
we're going to talk about, just how to do long division because, you guys probably haven't done this in a while. Okay? Yeah.
Put a 5 over the 5 and then put 40 under 45.
Okay, so, Mary said put a 5 over the 5 and 45 because 45 divided by 8, well, the closest you can get is 40. 8 times 5 is 40, right? You remember this?
Mm-hmm.
And then you subtract.
What is this?
What
Japanese?
difference is-
You've
Right?
never
That's
seen
like
this
4th
before?
grade.
I have. That was 4th grade.
Okay,
No,
so then
What- Where's the calculator?
45
didn't
minus
memorize all of
40 is 5, right? Yeah, there you go. Bring down the 3. Sure.
I remember, like,
So now 53 divided by 8. It's not going to be exact. What's the closest you can get?
6 divided by 53.
48.
Wait, hold on.
That's 48.
Yeah, 43.
What are you doing?
Hey, where'd you get the 6 from?
What are you talking about?
6 times 8 is 48.
53 divided by
Oh
8,
my gosh.
right?
You guys are
You're
so
not going to get a
sad.
nice whole number. You're going to get a decimal.
12, 13.
You're going really fast. I don't know.
No, this is 4th grade.
Yeah,
I'm not
4th
teaching you
grade,
guys
not
this.
in 11th grade. Like,
No, I'm not teaching you guys. Yeah, I'm not teaching you guys this. We're just reviewing it, okay? What's 53 minus 48?
8, 9, 6, 7, something. 8! It's 8! No.
Five.
You're
Wait.
like, you're like that mom that calls the names before you
No.
get the right
And
person.
then
Bull.
I was so confused.
Wow, why are we losing our minds over this plain
Now it's
English
8.
version?
Now it's
Because
8.
elementary school.
Oh no.
8 times 8 is 56.
So you bring down that last one, and now you have 58.
I was so confused.
Divided
I'm
by
sorry.
8. 7? Is that the closest?
No, it's 8. 7.
Okay,
What?
8 is 46. Right?
No?
56. Divide. What do we get?
Oh, I'm an idiot.
2.
2.
So guys, is there another number that you could bring down?
0.
You could, but you know what? We'll stop here. That means that this guy is your remainder.
Oh, yeah.
Remember that?
Oh, yeah.
Yeah? Okay.
Totally.
You remember the remainder.
567.2
Hold on. You
remaining.
remember this?
No.
You take the remainder and you put it up in the numerator. What goes below it?
R. Oh, the
The 8. Your divisor.
This was not how I was taught.
Oh, is that how you?
Wait.
Wait.
Wait, I have a question. Wait, I have a...
All right. So trust me, okay? All right, let's try this. If you look, we have a column for long division and a column for synthetic division, right? It's the same problem, yes?
Mhm.
Okay. If I have x minus 5 as my divisor, I can do synthetic division as long as it's a linear without a leading coefficient of, something other than 1, okay? So, since you guys just did synthetic division, let's do this. Synthetic division, when we're dividing by a factor, I need to turn it into the 0. So if it's x minus 5 as my factor, then my 0 is x equals what?
5.
Okay, so that's the number that goes on the outside, right? Then I draw my long L. And let me go and look at my dividend right here. And my biggest exponent is 3. Let me make sure that everyone is there and it's all in order. 3, 2, 1, number. Okay. Take just the coefficients, right? 1, negative 8, 17, and negative 10, yes? Okay. So, remember the first one just comes down and we have 1. Multiply, 5, add. Multiply, add.
I got 0.
Multiply, add. 0. Okay, but you know what? If you just tell me this, you didn't divide it. All you did, you did divide it using synthetic division, but this doesn't tell me what you got as your other factor, right? Each one of these has a place, all right? The last one is always your remainder. The one next to it is just your number, your constant. And after that is x, and after that would be x squared. If you had another one, it would be x to the what?
X to the
Third, okay? And so on. So this means that you have 1x squared, or just x squared, minus 3x, plus 2. Since we have a remainder of 0, I'm not going to put a remainder. I just stop here. This is what I get. That's my quotient when I divide that, right?
How would you put it?
No, it's not, because I told you synthetic division is not bad. Now, let's try the same thing with long division. Yeah. Yeah, what was your question?
How would you put a remainder if there was one?
Oh, okay, I'll show you. All right, so let's do the same thing with long division. We're going to take our divisor and put x minus 5 on the outside. Okay? Right. Okay. All right, and that's the regular divide. Yeah.
I'm gonna put a root sign.
Like that. Then division, and okay. So there we go. And then this whole first part, your dividend is going to go inside. So x cubed minus 8x squared plus 17x minus 10. Yes? Okay. So now, all right. So what we're doing is we're taking just that first term from each, okay? This first term on the outside and this first term on the inside, right? And what you're doing is you're asking yourself, what do I need to multiply to this x to get to x cubed?
No,
Right? You have x to the 1 power.
so
How
x
many
to the
more
3?
x's do you need to get to x to the 3rd power?
X to the second?
X squared. Okay. All right.
So then what do we put under that? Nothing?
Okay. Are we okay there? X. Okay. So then we have x squared. So now what you're going to do is you're going to take this number x squared, or this term, and you're going to distribute it to everything out here. Okay? X squared times x gives me x cubed, right? And then x squared times negative 5 gives me negative 5x squared. Yeah? Okay. So now, put parentheses around it, because we have more than one thing. You know, they're joined by a plus or minus. We can't separate it. And then, what do we do here? Oh, we subtracted, right? So, okay, subtract. Same process, right? The only thing that's different here, you have parentheses and you have a negative on the outside.
So that distributes.
You need to distribute that negative, yeah. Where did the x squared come from? It's because I need to look at this x out here and this first term, which is x to the 3rd, right? Basically, you're saying this divided by that. Like, if you have x, what do you need to multiply to this to get that? Okay? All right. So, let's see. X cubed minus x cubed gives me what?
0.
0. Okay, it should. All right, that first term should always go away. Okay, that went away.
Negative 3.
Now I have negative 8x squared
Plus.
minus a negative 5x squared. So minus minus gives me what?
Negative
Plus.
3x.
So negative 8 plus 5 gives me negative
3.
x squared. Does that make sense?
Mm-hmm.
You could always distribute the negative if you want to. Actually, you guys
yeah.
tell me if you want to do that. You can do negative, turn that. Okay? If you want to distribute the negative first, we can do this and then change the signs
Oh,
inside.
that's what you did.
So then x cubed plus a negative, that goes away. Negative 8x squared plus a positive 5x squared gives me a negative 3x squared, right?
Do we move the negative 3x to the top then?
Nope.
Okay.
So now, oh, because the exponents only change when you're multiplying or dividing.
Oh, okay.
When you're adding or subtracting, you're only working with the numbers in front. Okay. All right. So now we have this, and the second one needs to come down. Plus 17x. Okay. All right, so now we're going to look at these guys again. That first term, the x, now you're going to look at it with the negative 3x squared. X times what gives you negative 3x squared?
Negative 3x.
Yeah, negative 3x. Does that make sense?
Mm-hmm.
Yeah, it's weird. Okay, what's have to go? Okay, this times what gives me the first term here. Okay? So negative 3x. All right, so now you're going to do the same thing. You're going to distribute. Negative 3x times x gives you what? Yeah. And then negative 3x, different color. Negative 3x times x, no, times negative 5, sorry.
Yeah, but it's a negative times a negative, so isn't that positive?
Where's my green? There we go. We already distributed to the x. So now we do negative 3x times negative 5 is what?
Positive 15x.
Positive 15x. Yeah? Okay. So now I have this. I need to put parentheses around it and then subtract. Okay? And you know, I think it helps to distribute the negative here, right? So let's do that. Change this to plus, and we'll change all the signs inside.
Hmm?
Okay?
Why does that become negative?
Because if you distribute the negative,
Oh.
negative times a negative gives you positive, and negative times a positive gives you negative.
Okay.
So then what happens to this negative 3x squared plus a positive 3x squared? Cancels, which it should. If it doesn't, you multiply by the wrong thing, right? And then 17x plus a negative 15x gives me what?
2x.
2x. Okay. Do I have something else to bring down?
Yeah, negative
Yeah.
10.
Negative 10. So minus 10. Right? Let me see if I can get rid of all these highlights here.
Oh.
Okay. Nope, can't. All right. So now, what I'm going to do is I'm going to look at this x again, right? What do I need to multiply to this x so I can get 2x? Yeah, times it by 2. A positive 2, right? So then I put that on top. Positive 2. So then now distribute this 2 to everything out here. What's 2 times x? 2x. And what's 2 times negative 5? 10. Parentheses, and then we subtract. Right? But look, you know what? This, you could distribute the negative, but aren't you just doing 2x minus 10 minus 2x minus 10?
No.
What do you mean no?
The 10 switches to a positive 10 on the bottom, and
No,
then...
no, no, I know, but I'm saying you could distribute the negative, but aren't you just subtracting the same thing?
Yeah.
Yeah, so then it just cancel out, 0.
You can go 50 still.
Right? Is there anything left to bring down? No. Right? So now look at your quotient up here. X squared minus 3x plus 2. Isn't that the same as your synthetic division one? Right?
Yeah.
Okay.
That's correct.
It does. Since the remainder is 0, x minus 5 is a factor of that polynomial. All right? And then your quotient, that's the other factor. Okay? Let's try another one. I know this is weird. Listen, long division is not easy. Okay, but it does take practice.
Form first.
All right. Yeah, you want to do synthetic first here?
Mhm.
Okay.
Because it's easier.
So you have this trinomial divided by x minus 1. Okay, let's do synthetic first. So you're really going to divide by the 0, which is 1. Draw my long L. X squared, x, and a number. Good. So 1, negative 4, negative 5. Bring down the first. Multiply. Add. Multiply. Add. And remember, from the back, it's remainder, and then the constant, and then x.
Yeah.
Alright? And you know, guys, you're dividing. If you start with an x squared and you divide it by an x, then your quotient should be going down 1 degree. So it should be x, right? So
in a
this
roundabout
is,
way,
you're dividing a parabola by a linear, right?
yeah.
So then x minus 3. Oh, but then I have a remainder. So plus my remainder, which is negative 8, divided by, what was my divisor?
1.
No, your not your 0, but your factor, which is x minus 1. Okay. So just remember here in your denominator, you need to write the factor. Okay? Don't write the 0, write the factor. Okay? Yeah. Okay, because say you took this x minus 3 plus all of that and you multiplied it with this, x times x has to give you x squared. Right? But just remember this. Remember that it goes remainder, number, your constant, and then x. Okay? Then after that, x squared. And you know, when you're dividing, it has to go down one degree because you're dividing it by 1. You know what I'm talking about? From
No, I
x
have-
squared.
yeah,
Okay? Where are you lost?
I don't.
Well, it's this. If you have x squared and you divided it by x, what should you have? Just x left over. That's why you have just x left over. That's what that is.
Well, what I'm saying is like how you divide it. You take one, multiply it by one, and then there. No, I just don't know.
Well, I mean, it's synthetic division, so
So it's
it's
like
kind
a
of like
roundabout.
made up division. No, it's not roundabout. No, that's actually a lot more straightforward than I think long division. All right, so long division. Let's do this one the long way. X minus 1 on the outside. And inside I have x squared minus 4x minus 5. And you know, give yourself a lot of room if you need to with these at first, okay? All right, so again, we're looking at just the first terms. X times what gives you x squared?
X.
X. Okay. So now we distribute to everything on the outside, right? X times x gives me,
What's the second?
and x times negative 1 gives me,
That's
good, parentheses subtract. Okay? And then we said it was easier if we just distribute here. So we'll change this minus to a plus. Opposite signs of everything inside. Okay? Because you have to distribute that negative.
Negative 3x.
So, x squared plus a negative x squared, of course, they should cancel out, right? Negative 4x plus 1x is what?
Negative 3x.
Yeah, negative 3x. Now, gotta bring down this minus 5.
Is that your remainder?
No. You still have more to divide if you still have more inside here in your original. So now, I need to do the same thing. This x out here and this negative 3x. What do I need to multiply to this x so that it looks like this guy, negative 3x?
3.
Negative 3. So now, let's distribute. Negative 3 times x gives me negative 3x. Negative 3 times a negative 3 gives me plus 3, right? Because we're multiplying. Okay, and then parentheses, subtract. Yeah?
Add minus.
And minus, okay. Right? Negative 3x plus 3x, well, those should cancel out, right? Negative 5 plus a negative 3 gives me
Negative 8.
negative 8. All right, and here, Isaiah, this is your remainder because you don't have anything else to bring down. So if this is your remainder, well, then now you're going to go up here, and you're going to say, okay, well, then plus whatever your remainder is, divided by this remainder over your divisor.
Oh, I see.
Divided by x minus 1. Right? Which was your divisor. And then if you look, well, then that's the same thing as the synthetic. Okay? So down at the bottom it says, since x minus 1 does not go evenly into that polynomial, this has a remainder, and we write remainders as plus, yeah, r over the divisor as a fraction. Okay? Yes?
Why do you add the remainder fraction?
Instead of putting just a minus. You know what? I wonder if that's just something I do.
What is it?
Why do I put plus here instead of just saying minus 8 over x minus 1? I think I do that because of the bottom being a factor. I don't think it really matters.
It doesn't really matter.
I don't think it really, right? It doesn't really matter.
Because it doesn't have a plus or minus on the regular division.
Mm.
So like, do you have to have?
You're
do you
right.
have to have a plus or minus?
We do with these. Yes, we do with these because in the regular division, you're not doing like 8 plus x. You're doing just 81. But with these, you have like x squared minus, and that's why you put plus. Okay. Yeah. But it doesn't matter if you put plus or if you just said minus 8 over whatever. I use plus. I think it just looks better. Okay. So what to use for which method, right? Okay, we use synthetic division when your divisor is linear. Alright, so it's just a plain old x minus 1. Or it's just a plain old x plus 2. That's when you can use synthetic. Yep, that's all I have. Okay. Alright, but when you use long division, right? When your divisor is not linear. Okay, so maybe you'll have like x squared minus 1.
Oh, so that would be a quadratic.
Yeah, that's a quadratic. Or maybe you'll have x cubed plus 2. I don't know, right? It's not linear. Or if it's linear, with a coefficient that's greater than 1, with a leading coefficient, I should say. There. Greater than 1. So it would look like this, 2x plus 1. Something like that. Okay, you can't do synthetic division with that one, okay? Yeah.
So more times than not, you probably like use long division.
You use long division if it looks more complicated. Oh, here's another one for this. That just reminded me, thank you. 2 terms.
What is example of 2 terms?
2 terms like x minus 1, x plus 2.
What do you mean by linear?
Linear? Oh, it means exponent, the biggest exponent that you have is 1. Like it can't ever be x to the something power. Okay? So 2 terms. Long division, if your divisor is more than 2 terms. Sure, there was a third one for synthetic.
That's probably why there's 3 ones.
Purple. So something like that, right? That would be 3 terms. You could have something that's 4 terms. We're not going to give you anything like 4 terms, okay? I think our divisors, the most would be the divisor. The greatest would be 3. All right, so let's look at number 1. Basically, if it looks a little bit more complicated than just a divide by x minus 1 or x plus 2, you have to use long division, okay? So number 1, dividing using long division. Okay, let's do this.
3x.
I'm sorry, what?
Why do you
Oh, for this one? Oh, because it's 3x plus 1. That's why. If you have a number in front of that x, you can't use synthetic. Okay? All right, so we have 3x plus 1 divided by, what do we have in here? 3x cubed minus 5x squared, 3210. Okay, minus And you know, just like the synthetic division, if I was missing a term, right, I would probably put in a 0x whatever for the missing one. Kind of act like a good place marker. All right, so first term, 3x. What do I need to multiply to 3x to make it look like 3x cubed? Huh? X squared. Good, thank you. And then distribute that x squared to everything on the outside. X squared times 3x gives me 3x cubed. X squared times 1 gives me x squared. Yeah? Parentheses, subtract. Now we want to distribute that negative, so plus, minus, minus. Okay? Now let's add 3x cubed plus a negative 3x cubed. Of course, should cancel out. Negative 5x squared plus a negative x squared gives me negative 6x squared, yeah?
Negative 2x.
And then bring down your plus 10x, right? Just bring down one at a time, okay?
Would it be negative 2x that goes on top?
Okay, so let's see. This first one on the outside and the first one on the inside. What do I need to multiply to 3x to get negative 6x squared?
Negative 2x.
Negative 2x. Yep, negative 2x. Good? Yul, you good? Yeah, you sure? So negative 2x times 3x gives me negative 6x squared. Negative 2x times 1 gives me minus 2x. Yeah? Getting it? Okay, good. Parentheses, subtract. And then let's distribute. So plus, plus, plus. Okay, so I have, down a little bit. Negative 6x squared plus 6x squared. Okay, they should cancel out. 10x plus 2x gives me 12x. And then bring down your minus 3. All right, and then let's repeat. This 3x times what gives me, oh, I can't see it. Yeah, times 4, thank you. So a positive 4. Right? Not bad. Okay. So 4 times 3x gives me 12x. 4 times a positive 1 gives me a positive 4. Parentheses, subtract. Right? Distribute your negative, so plus, minus, minus. Of course, the first ones cancel out. What's negative 3 plus a negative 4? Negative 7, do I have anything else to bring down? No, so this is your remainder. So I'm going to say plus negative 7 divided by, what is my divisor? What was that factor? Thank you, 3x plus 1. And here you go, this is your quotient. Okay? Mrs. R, are we okay with them leaving this as their answer as long as it's neat and legible? You guys don't have to copy it over again as long as we can kind of read that clearly. Yeah. Okay? Is that the next one?
Yeah, but it doesn't make sense.
All right, let's go to the next one then. Questions about this one? All right. Okay, let's look at this. So this one definitely long division because the divisor is x cubed, x squared, I'm sorry. All right, so we have x squared plus 3. All right, x cubed, 3, 2, 1, and constant. Okay. Alright, so the same thing. First one, first one. What do I need to multiply to x squared to get it to x cubed? X. Distribute to everybody.
Do you
Whoa.
see that now?
Do you guys see that? Weird. What happened? We went from x cubed to 3x, right? So, you didn't do anything wrong. You can just put 3x right below. But you know what? 3x, if I wanted to be, a little bit more careful, I want to line it up right underneath the other x term, right? So then, means this one just gets a 0x squared. I don't have an x squared term to combine with that, right? So I'm just going to put a little filler, okay, so that I don't accidentally go and combine my x squared with my x term, right? All right, so parentheses,
Negative,
subtract.
negative.
Okay, so then distribute your negative plus minus whatever with the 0. I don't really care about the 0 there, right? Okay. All right, so if we add, okay, x cubed minus x cubed, of course, cancels out. Negative 5x squared plus 0x squared, negative 5x squared, right? Okay. And then 3x plus a negative 3x, or 3x minus 3x, that cancels out. Yes? Do we have anything that we need to bring down? Yeah, so minus 15. Do you see that? That one was a little bit tricky. If you're not paying careful attention to that one will get you. All right, so we're doing the same thing. Look at this x squared. What do I need to multiply to it to make it look like negative 5x squared? Good, negative 5. Good job. So negative 5 times x squared gives me, yeah. And what's negative 5 times a positive 3? Okay, I could put parentheses, subtract here. What do you guys notice about this?
It's all going to end up being 0.
All cancels out because it's negative 5x squared minus 15 minus the same exact thing, right? So they all cancel out, or you could do this. It's fine. They all cancel out. No remainder. That means x squared plus 3 is a factor of this polynomial, and your other factor is x minus 5.
So
Yeah?
how do we set that up?
What do you mean? What set what up?
How do I rewrite it?
No, you don't have to rewrite anything. This is your answer right up here in black. X minus 5.
But I want to rewrite it, so I
One
would.
x minus 5.
We got
That's
0.
not part of the answer.
No, this is your divisor. You divided it, so then this is your quotient.
Oh.
That equals x minus 5.
So if you get the 0 at the end, we got 0. So if you get the 0 at the end, that just means that you did it correctly?
No, that just means you have no remainder.
Oh, no remainder.
And that means that this x squared plus 3 is a factor of this polynomial.
That's fair.
Okay. Any questions about this? All right. Yeah. No. I like that you asked though, but no. Don't we have like 4 minutes left?
Yeah.
We can do this one then. Oh my goodness.
No.
Oh my goodness, save the best for last. Oh.
Yeah, exactly. Let's save this. Let's save this for last, when we get
Oh
home.
no, because if you guys see this on the homework, you're gonna freak out, and then it's gonna be.
We'll just Google it.
You didn't teach us this.
We'll YouTube it.
Let's do this one. You know what though? How about this? I'll go a little bit faster with this. Okay.
Yeah.
All right, let's go. All right, let's go. X squared, x cubed. X squared times 1 gives me x cubed. X. Distributed to everything. Oh, have fun. 3 times. Plus 2x squared plus 7x. Parentheses subtract. I didn't ask a question. Don't talk to me. I'm focused.
Yeah.
X cubed minus x cubed crosses out. 4x squared minus 2x squared equals 2x squared. 4x minus 7x gives me negative 3x. And of course, bring down that last guy. So short. We're almost done. All right. X squared times what gives me 2x squared? 2. All right. Positive 2. Then distribute to everybody.
Why do you distribute? Oh,
Because
yeah.
that's what we do. Parentheses subtract. And then plus, minus, minus, minus. It is so much more fun in fast mode.
Right?
Yeah, we should do this more often. There we go. Negative 7x minus 11. Is there anything to bring down? So this is my remainder. Plus negative 7x minus 11 all over x squared plus 2x plus 7. And we're done.
Yeet.
Yeah.
Be done
All right.
now.
I mean,